Hi everyone, my name is Nicolas Cazur. I'm from the McGill Applied Remote Sensing Lab, and today I'm going to show you how not to destroy your brand new shiny drone. A lot of people have been using Google Earth to plan their DJI PILOT missions. Now this is a problem because the images that we're seeing have considerable relief displacement. Okay, let's have a look at this image in QGIS. As we can see, we have a clear view of the size of the building. This indicates that we have relief displacement. We're not dealing with a true orthophoto. If we use the base map from the city of Montreal, we can see that there is definitely some problems here. If we measure the distance between the top of this tower here and where it should be, we're dealing with about a little bit over 6 meters of error. So if you've planned your mission with a 5 meter buffer, then you might be running into some problems. Of course, the advantage of planning a mission within QGIS or within Esri ArcMap is that we can use other data sources. In this case, I've downloaded the City of Montreal orthophotos, and we can see that we still have a considerable amount of problems here, although the relief displacement has been shifted in another direction. So probably the best base map would be the LiDAR data. In here, we can see that the LiDAR data has no relief displacement, and this is a great way to plan a mission. Okay, let's zoom out from this area. What we are going to do is we are going to plan a 3-day mission. So if we look at this area here, in day 1, we will have the first mission around the McTavish pumping station, and a second mission, which will be on the McTavish Reservoir. On day 2, we will be concentrating on the Percival Molson Stadium, and on day 3, we will do a simple waypoint flight between both areas. Now, DJI Pilot uses KML files. Now, of course, KML files that are exported either from ArcMap or from QGIS can be problematic in DJI Pilot. So this way, we're going to be using simple shapefiles. As we can see, the shapefile absolutely needs a name and a comment section. If you do not have these fields within your shapefile, the software that I'm using to translate the shapefiles into the KMLs will not work. Now keep in mind that under the name field, this name that we have here will also be used to create the output file names. So please use characters that are compatible with your operating system. Okay, so I've placed all of my my mission files within this directory. You'll notice that one of them has been projected in MTM Zone 8, which is a current coordinate reference system in Montreal. Of course, KML only worked with WGS84 data, so this file will be reprojected. Here in the background, we have the Spider, which is a text editor for Python. And what we have here is the software that I have created in order to translate these files. Now, the only thing, a lot of you don't really know Python, so I've made this fairly simple. All we need to do is to copy the input directory and to place it in here. Once we've done that, we make sure that the name field is set to the correct field. This is the field that you find within your file, and the description field is rem. Now you can call this however you want, but you need to correct the information here. So we have a name field and we have a rem field. This will be used in the output for the KML. Once the correct information is put, we will simply run the script. we'll see here that it's found 3 files. It has been translated, and we have, it says here that the day 2 file has been reprojected to EPSG 4326, which is WGS 84. And it also does the day 3, which is a line file. If we look at the output now, we have a new folder. The name is taken from this variable here. And inside, we can see that we have KMLs for every file that we have. So in the first file, there were 2 zones, and we have 2 KMLs. Here we have day 2, which has a simple shape, and then we have a path here. So the important thing is that it will take whatever shapefile it finds in this directory, and it will translate it to a KML in this directory. Now, thankfully, every KML that you see here is 100% compatible with DJI PILOT, which is not the case if I had simply exported the shapefile from QGIS to KML. Same thing happens in Esri. Okay, so if you're new to Python, this might be a little bit overwhelming. So in the next part of the video, I'm going to show you how to set up your Python environment to make the software work. You will need OS, which is a standard library in Python. System is also a standard library in Python, but you will need to install GeoPandas and Simple KML. If you're going to start programming in Python, I strongly recommend that you install the Anaconda Individual Edition. It is a free open source, but you can also buy professional packages that do come with some support. Simply Google Anaconda Python and you will be able to find it. Now, when you do the installation, you will be asked 3 things. You will be asked if you want to install Anaconda Python for just you or for every user in your computer. I think I would choose just you because installing it for everyone in the computer requires some the administration password, but will also complicate things a little bit later on, especially if you're adding some new channels. We will talk about channels a little bit later. The second thing that is very, very important is you will be asked to add Anaconda 3 to the Python, to the system path environment variable. I would select no. And most importantly, you will be asked to register Anaconda 3 as the system Python 3.7. I would definitely say no to that. And the reason is that if you do install Anaconda 3 as your system Python, then softwares like Esri ArcMap or QGIS might want to start looking into that version of Python to run its code, and that will definitely give you problems. If you do run into this problems, well, simply Google it and you will find lots of resources to fix this. Installing Anaconda will give you what we call the Anaconda Navigator. The Anaconda Navigator will give you a graphic user interface to the Python distribution. You can install additional software using this user interface. Jupyter Notebook is one. Spider is also another. Spider is a very powerful Python IDE, and it's made for editing Python code. You can also create various environments. And the nice thing about environments is that if you create an environment that has packages that are incompatible with another program, then you can create an environment that will be specific to your software. So you can see that you can install Spider directly in within this environment, but this is not something that is no longer recommended. And the reason is that Spider required a specific version of Python and a certain number of packages, which can come in conflict with other packages that we're trying to install. So if you go over to the Spider webpage, you will find that they now have a Windows standalone installer, and I definitely recommend that you use this Windows standalone installer. So this would be the second thing that you would need to install. I guess the number one error that people will do is that they will try to install their packages in the base root of the environment. That is a very bad idea. I strongly recommend that you start with um, a new environment. So what we are going to do is create a new environment that we are going to simply call P38 for Python 38. Do not put any spaces, any funny characters in here. And then I would definitely create this environment. And notice that you can also install R. So this is a very interesting package for scientific computing. Okay, so we now have a Python 3.8 distribution. So once we have installed this, we are going to head over to the Spider IDE and point it towards this new distribution. So what we need to do is simply open Spider. Then we go into the tools, go into the preferences, and then select which Python interpreter we want to use. So you'll notice here that default is the same that in which Spider was actually built. I don't recommend that you use this, but you definitely want to select another one. And we now have the environment P38 Python, and we are going to select this. Of course, when nothing works, you need to restart the application. And now we will have an error. The error is in the console. And what this says is that if we want the IDE to work, we basically need to install what they call the Spiner kernels. And this is a module that we will be installing in Anaconda Navigator, and we need to install equal or above 2.1 or lower than 2.2. To do this, all we need to do is go into the specific environment. We update the index, and we are going to look for Spider. I've been waiting because I'm under the installed section. So let's go to the not installed. So we want to install the Spider kernels only. So this should be just fine. If we right click, we could mark it also for a specific installation number. So we are simply going to go for install, apply, and this is the equivalent of writing conda install inside the terminal. So it's going to find all of the packages that it needs to run. So experiment tells me that it's not a good idea to install the entire Spider within this environment. By installing the Spider kernels, we seem to reduce a lot of the possible conflicts that we can have. So while this is installing, I'm going to turn off Spider. So I believe it has been installed. And we are going to start the Spider again. And in theory, if everything goes well, we should have a working function, a working version within this new environment. Okay, so now we are back into the navigator, and we are going to install the GeoPandas. To get any information on the GeoPandas install, I simply recommend that you Google it, and it will give you the Conda install geo package. This can be run directly inside a prompt. You will find this prompt on the side here. It's called the Anaconda prompt. But this can also be done using the navigator. So what we will do is simply look for packages that are not installed. Make sure that you click on the environment and GeoPandas, and we will install GeoPandas. As we can see, GeoPandas has now been installed. If you do run into problems, I definitely suggest that you start with a new environment. This is especially if you important if you happen to install a lot of other packages before this one. Now, if we you might want to also install packages using what they called channels, different channels. So there's the Conda Forge channel, which is possibly a little bit more cutting edge, and they strongly recommend that you either install everything from default channels or everything from the Conda channel. If you have any questions about installing Conda Forge, you have instructions here, or you can simply go to Conda Forge and figure out how you can install these different packages. The packages and channels can be installed by adding a channel here. So for now, we are using the default channel. The last thing that you will need to install for the software to work is a simple KML. Now, if we type here, simple KML, let's go into the not installed. We will see that is not available as a package. So what we will need to do is simply go to the simple KML website, figure out what we need to do. So we need to type pip install simple KML within the Anaconda prompt. As we can see, currently we are into the base environment. So we will activate the environment. So we are now into the P38 environment. You will cut and paste and use pip, which is another installer, and that will complete the installation. Once this is done, we're all ready to go. As we can see, if we go back into the environment and we type for simple KML, we can see that pip install did indeed install the simple KML, and it is now part of the packages. Okay, so we are now back in Spider. If we write Conda info, we can see that we are in the P38 environment that we created. And if we go beside this line and press F9, you can see that the OS has been imported, the system has been imported, the GeoPandas library is also being imported, so there are no errors, and the simple KML. So now we know that the environment is working. The only thing we need to do is to point the software towards the correct directory. Make sure that the name and description variables are correct, and then run, and everything should work. Thank you very much. So if you have any questions, you can just go over to my GitLab page at gitlab.com /NJA Cadieux, CADIEUX, and in here you will be able to access the the various projects that I'm working on. And if you want some of these projects to be modified, you're free to contact me. Thank you very much.